Do you feel the vibes?
Okay, so we're gonna continue this period, and we're gonna finish up this lesson. We had talked about end behavior last, right? That was the last thing we had done, right? Was the end behavior. And remember, we're using like the limit notation for that right now. Okay, so with these, okay, so I have used your graphing calculator to graph each function, but you know what? For the time being, let's not, right? Because some of this we can actually do without our calculators, right? So basically, we want to figure out all of these things. All right, so first thing it's asking is discontinuity and type. Looking at this, do you anticipate any discontinuities on this function? No, it's a polynomial function. The domain is all reals. When the domain is all reals and it's a polynomial function, there's not going to be any discontinuities. Okay, so none. Okay, right end behavior and left end behavior. What do you guys think? What do you think? Right end behavior. So what do you think this will look like? Yeah, right? So you already know from last year, right? That this is an x cubed graph, right? And then especially at the infinities, right? All of these other terms become negligible, and it's only that x cubed graph that takes effect. So regardless of what's happening in the middle here, it's going to behave like an x cubed graph at the very ends of it, okay? So the right end behavior, limit of f of x as x approaches infinity, will be infinity. And as x approaches negative infinity, that will be negative infinity, right? Right, if there was a negative in the front, if it was negative x cubed, right? So for the zeros, we should plug it into the calculator, right? So go ahead and plug this into your calculator very quickly, and let's see. Okay. Were you guys able to plug this in? Okay, I don't think I need to plug it in, right? You guys are okay with that. What are the zeros for this? Right, so negative 2 and 0, let's write it in coordinate form 1 and 2. Okay? Okay, so for the next one, do you anticipate any discontinuities for the next one? Where? X equals 0. And what kind of discontinuity would you anticipate for that one? It's an infinite discontinuity, right? So infinite discontinuity at x equals 0. All right, so go ahead and graph it and let me know what the end behavior is going to be. How did I know it? Oh, how do we know it? Well, okay, so the discontinuities, when you have a rational function, you have to look at the denominator. And if the terms in the denominator will not cancel with anything in the numerator, when you set that denominator equal to 0, whatever the x value is, it's where you have a discontinuity. And when it can't be canceled, it's infinite. When you can cancel it, it's removable. Okay?
If you cancel it first, then you don't have to do 0.
Well, then it would be a removable discontinuity. Okay. Yeah. Okay, so what about right end and left end behavior? Yeah.
Is there like a way of knowing that like the right end behavior, or not
Yeah.
end behavior, they're like just like the limits from the right side and the left side, like without using the graphic?
Are you talking about at a point or at the infinities? Yeah. Yes. If it's just a polynomial function, normally you plug in it. So throughout the year, we're gonna go through all of those details.
Oh, I just need
For right now, like you know how remember how we were plugging it in for the most of the time you can plug it in. Yeah.
I'm
Okay.
still like struggling, like knowing if it's like a different point, like a different y value, same x value.
Right.
How you would know that.
well, you'll have like the graph. Okay, so let's do this one. What is the limit as x approaches infinity? Did you guys graph it?
Yeah.
So what is it as, huh? Somebody said it. Who said it? 0, right? It approaches 0. And as x approaches negative infinity? 0 again. Okay, so what are the zeros for this? Are there any zeros? No, there are no zeros. Huh? Yeah.
There are some questions where it's the limit of f of x as f approaches -4 is 1. And the only way I could figure it out was just by looking at the graph on my calculator.
Are you talking about like the homework?
Yeah.
Okay, why don't we talk about homework at a later time? Right now, I just want to focus on this page. Okay? Yeah.
I thought there was zeros.
Well, did you graph it?
Yeah.
Does it cross the x-axis?
Yeah, when I pressed analyze for zeros, I had some. Yeah. That's
Oh.
why I'm confused. I had some.
Okay, all right. Let's see. You know what? I haven't graphed this, and I was just trusting you guys. Okay, so let's see. Let me graph it. So this is going to be x squared plus 3x minus 5 over x cubed. Oh, okay. So there's definitely a 0 here, right?
Yeah.
So menu, analyze graph, 0. There's definitely a 0 here at 1.19. And then it looks like there is a 0 over here as well. So do you see how it crosses over here? So menu, analyze graph, 0 here as well at -4.19. So there are 2 zeros. Thank you. So -4.19 and 1.19. Okay. All right. Next one. Determine the value of a so that f is continuous. Not that, the other stuff in this chapter are not important, but this is especially crucial for you guys to know, right? As we're heading into, right, calculus and all that good stuff. Okay. So determine the value of a so that f is continuous. What do we see here? There is a piecewise function here, and the partition is at x equals 2, correct? Now, on the one hand, we have x squared plus 1. Okay, we know exactly what that, by the way, when you're solving these, you are never going to graph them, okay? This is not something that we want to waste our time graphing. The only reason why I'm sketching for you guys right now is so we can visually see what's going on. So x squared plus 1, we know exactly what that looks like, right? This is the vertex here, and then when x equals 2, what's y? 5. So what am I? 1, 2, 3, 4, 5. Okay, so it's like this. There's an open circle there. Okay, that's like a parabola. Okay, that's a horrible looking parabola, but you guys know what I mean, yeah? Yes? Okay. And then I have ax here. Ax is a linear function. I want it to be continuous. So depending on what a is, right, this other function, it could look like this, or it could look like this, or it could look like this. Okay? Which one of these makes this function continuous? Which version? The middle one, right? So basically, I want to pick the correct a so that it's continuous. That means the limit from the left has to equal the limit from the right. Okay? So from the left, okay, f of 2, well, I don't want to say f of 2. From the left, the limit of f of x as x approaches 2 from the minus side, right? I plug 2 in here, and I get 5. From the right, the limit of f of x as x approaches 2 from the right-hand side is equal to, I plug 2 in here, is 2a. For it to be continuous, the limit of f of x as x approaches 2 from the minus side has to equal the limit of f of x as x approaches 2 from the positive side. That means 5 has to equal 2a, so a is 2/5. Okay? Huh? Oh my god, 5 over 2. Hey, such a rookie mistake. I don't know why I'm so off today. Okay, so 5 over 2. All right? Okay. Questions? All right. So a car rental company charges a base fee of $35 to rent a car, as well as a daily fee of $15. Write an equation that models the total rental fee as a function of the number of days n. Okay, you've been writing equations like this since you were in like the 5th grade or 6th grade or 7th grade, whatever, okay? So the point of this is just the skill of like notation and everything. So take a look at what this says. Write an equation that models the total rental fee as a function of the number of days n. Okay, that means we want to write a function f of n. Do you see that? Right? You know those like Drake memes, right? Where it's like one thing and then you're like, yeah, that one, right? Like this is like, okay, you can write like y equals, or it's like f of n equals, right? It's like now like elevated, right? Okay, so f of n. So how much is this thing gonna cost? So $35 plus 15n. I mean, again, you've been doing that since you were like little, okay? As the number of days increase, what value does the cost approach? Okay, so we know exactly what this looks like. If this is 35, we know that this looks like this, right? So as the number of days increase, it means as n increases infinitely, okay? So this is now a limit question. So the way you write it is the limit of f of n as n approaches infinity will be what? How much would the cost approach? Infinity. And that makes sense, right? If you rent for for like 75 years, you're going to pay a lot of money, okay? All right, again, on the homework, right, you're probably going to have one of these problems that is a little bit more complicated to write the equation. But the point is, you write the equation and then you reason out, what the limit is going to be. Okay? All right. So now, okay. So take a look at this homework, right? This is 1.3, right? This was the homework? Yeah. Okay, so we have so number 1, for example, you wouldn't be expected to know what the graph of that looks like.
So this would be on the calculator?
Right, either it would be on the calculator or I would give you the graph. Okay? I don't know. But at x equals -5, this is continuous.
Yeah, but what do you mean, like, for this problem, you don't need the graph, right?
Huh?
For this problem, you don't need a graph.
Well, you need to find out what the limit is at x.
It's saying at x equals 5.
Okay. No. So it says determine whether it's continuous at the given values. Justify using the continuity test. To justify using the continuity test, you have to say right, with the 3 steps. Okay? So to justify using okay, this is continuous at -5, okay? But to justify it, you have to use the 3 steps. So for example, f of -5, you have to actually say this. F of -5 is how much? Root 21, right? And then and then you have to say the limit of f of x as x approaches negative 5 is equal to what? So now you graph this, right? So you have the square root of, or is the square root? X squared minus 1, was it? Oh, minus 4. That does change things. Right. Okay. So how much is root 21 these days? 4 point something, right? So now we're looking at x equals negative 5. So let's go to menu, analyze graph. I'm sorry, trace. Graph trace. So at about negative 5, right? As I'm approaching negative 5, is it going towards root 21? Right? You see that the values are approaching root 21, okay? So now let's look at it from this side. As I'm approaching negative 5 from this side, are the values approaching root 21? They are. So then I say, okay, the limit is also, root 21. So number 3, since f of negative 5 is equal to the limit of f of x as x approaches negative 5, therefore, f of x is continuous at x equals negative 5. Okay, hang on. Okay, so saying it's continuous, fine. But the most important part of this is this sentence that says justify using the continuity test. This is the pre-calculus part of pre-calculus. Okay? Yeah. Yep.
My question. For number 2, I remember in past ones we did like 3 different limit things. How come we did one? Like, how come you didn't test it from the other side and write it down?
Because that was a piecewise function. This is not a piecewise function.
So you only
We
have
just
to-
visually inspected it. So that's how you have to do for all of these, right? That's what you have to do for all of these. And then, so let's see. So like, look, 23 to 27, right? 23 to 27, you see these graphs? None of these are things that you'll be expected to graph on your own, right? So when I have a graph like this, when I have a function like this, you'll be given the graph, okay?
Would you be able to know what discontinuities are where just based on the function?
Well, this one is just, okay. So this one, it's asking you for the end behavior. So the limit of f of x as x approaches infinity. Okay. If let's say I had given you, number 22 for, what we did for number 1, then yeah, you have the function and the graph, right? So you would say, okay, number 1, f of 2 is, you plug it in. Then you look at the limit. Okay, the limit is fine. You know what I mean? Like you could still do that. Yeah.
How do you support it?
Don't worry about that. Don't worry about supporting numerically. Just write the end behavior. I literally just said you didn't have to do that. So yes, it's totally fine. Okay, number 31. Okay, graph. What does the end behavior? Okay, so
Were we supposed to write anything for A, or is that just like
no, it just says graph using. But then when it says graph, now show the graph on your homework, right?
So I sketching?
Yeah, but like, so for 31, you would have to show the graph on the homework, but as it applies to this physical problem, right? So this is a catalyst used to increase the rate of a chemical reaction. X is the concentration of the solution, okay? So your graph should not have any negatives, right? Because if this is R and this is R of X, I need to see this, okay? This is X, this is R of X. The concentration can't be negative, and neither can the reaction rate. Okay, so like it's just going to be in the positives here. So it'll probably look something like this. So now look at this again tonight based on everything we're doing. And then so for part A, show me this graph, but calibrate this correctly, okay? Or like something that makes sense. What does the end behavior of the graph mean in the context of this experiment? That's it. Never support the conjecture numerically. We're not doing that. So, but like you have to say it, right? You have to say, for example, just like what we did for the car, right? So, as the number of days increase, infinitely, then the, whatever. Okay? So you'll either say the value of, R of X increases infinitely, or it approaches a certain number, right? So go ahead and try that out for tomorrow. And then 45. What's 45? So here again, graph and figure out the discontinuities. 53. Oops. Okay, so again, graph and describe its end behavior. So all you have to say is like limit of f of x, blah, blah, blah. And then I think the rest are pretty much the same. Okay.
What work do you want us to do?
For which one? Well, just write the function and then say limit of f of x as x approaches infinity is this, and then, okay? So I just taught that one. So why don't you do it now using what I taught you guys, okay? So remember, for this one, you have to do two things. One at -3 and then one at 3. So left and right at -3, left and right at 3. Okay, so go.
You go to 3, 5.